DNS request amplification. DNS request amplification is a popular and highly effective distributed denial of service (DDoS) attack. It is a force multiplier attack, meaning an attacker can use a relatively small amount of bandwidth to crush a target with a massive flood of data. It relies on two main pillars, IP spoofing and the asymmetric nature of DNS queries. How the attack works: the attack follows a specific four-step cycle that turns public DNS servers into weapons against a target. 1. The spoof. The attacker sends a DNS query to a recursive DNS resolver. However, they spoof the source IP address, making it look like the request came from the victim's IP address instead of their own. 2. The payload. The attacker specifically requests a record type that results in a very large response. The most common choice is an any query or a large DNSSEC record. 3. The amplification. The DNS resolver receives the tiny request, example 60 bytes, and generates a massive response, example 3000 to 4000 bytes. 4. The impact. The resolver sends this massive response to the spoofed IP address, the victim. If the attacker uses a botnet to send thousands of these requests to hundreds of different DNS resolvers, the victim is suddenly drowned in gigabits of unsolicited traffic. The amplification factor. The efficiency of this attack is measured by the ratio of the response size to the request size. Standard query. A 60-byte request resulting in a 512-byte response yields an amplification factor of roughly 8x. EDNS 0/DNSSEC. Using modern extensions, an attacker can achieve amplification factors of 50x to 70x. This means an attacker with a 1 Gbps botnet could theoretically generate up to 70 Gbps of traffic directed at the victim, enough to knock most medium-sized networks offline instantly. DNS request amplification is a very well-known and clearly classifiable attack type. Here is the precise classification and where it fits in a security taxonomy. Prevention and mitigation. Because the traffic comes from legitimate DNS providers, like Google 8.8.8.8 or Cloudflare 1.1.1.1, blocking it at the victim's end is difficult. Mitigation usually happens at the network or provider level. Strategy description. BCP 38, Ingress ISPs should block any outgoing traffic that has a source IP address that doesn't belong to their network. This filtering prevents spoofing at the source. Disabling open DNS servers should be configured to only answer queries from known or local IP ranges, rather than the entire resolver's internet. Rate limiting, RRL, DNS software, like Bind, can be configured to limit the rate at which it sends responses to a specific IP address. Large enterprises use scrubbing centers that absorb the massive traffic and filter out the junk DNS responses anycast/scrubbing before they reach the actual server. Classification of DNS request amplification. Primary category, rightward arrow distributed denial of service, DDoS, rightward arrow subtype, volume trick amplification attack, rightward arrow subtype, DNS amplification attack. DNS amplification is one of the classic reflection plus amplification DDoS attacks, alongside NTP amplification, SSDP amplification, charge-in amplification, etc. Why it is an amplification attack. DNS resolvers respond with a larger reply than the request sent. Attacker sends a small forged DNS query, with victim's IP as the source. Open DNS resolvers respond with a large DNS response to the victim instead of the attacker. The victim receives multiplied traffic volume. Amplification factors can range from 20 times to 100 times plus, depending on DNS record types, example any queries. Why it is also a reflection attack. Because the attacker spoofs the victim's IP, sends requests to third-party DNS servers. Victim receives the responses. Rightward arrow traffic is reflected, so it belongs to reflection-based DOS attacks as well. Exact placement in a taxonomy. Here is the hierarchical placement: network attacks, denial of service, DOS, distributed DOS, DDoS, volume trick attacks, reflection-based attacks, amplification attacks, DNS amplification attack. This is the most accurate technical classification. Characteristics of DNS request amplification. Feature description: attack vector UDP port 53, DNS, traffic type large response floods direction from DNS resolvers. Rightward arrow victim attack technique: spoofing plus reflection plus amplification requires open resolvers. Yes, misconfigured DNS servers. Goal: overwhelm the victim's network bandwidth. Example scenario: attacker sends a 60-byte DNS query, example any request, to a list of open recursive DNS resolvers. Spoofing the victim's IP resolvers send back 3000-byte responses to the victim, causing bandwidth saturation. Amplification equals 50 times in this example. Major amplification attack types. Amplification attacks are a subcategory of DDoS attacks that exploit the bandwidth asymmetry between a request and a response. Most of these attacks leverage UDP-based protocols because they don't require a handshake, making it trivial for an attacker to spoof the victim's IP address. Complete list of major amplification attack types. Amplification attacks exploit protocols that use UDP, stateless, spoofable, respond with larger replies than the request, allow queries from untrusted sources. They are almost always used for reflection DDoS attacks. 1 DNS-based amplification. DNS amplification uses any queries, DNSSEC-enabled zones, or large text records. Amplification factor, 20 times, 100 times plus. As we discussed, this exploits the domain name system. The attacker sends small queries for large records, like DNSSEC or any, to open resolvers, spoofing the victim's IP. Key vulnerability, open recursive DNS resolvers that accept queries from anyone on the internet. 2-time synchronization protocol amplification. NTP amplification, monlist, NTPDC, famous monlist vulnerability. Amplification factor, up to 550 times, one of the highest historically. This is one of the most efficient attacks. Attackers use the monlist command on older NTP servers. This command returns a list of the last 600 IP addresses that have interacted with that server. Key vulnerability, the monlist feature in NTP versions older than 4.2.7. A tiny 48-byte request can result in a massive multi-packet response. 3. Network Service Discovery Amplification. SSDP amplification, UPnP, exploits UPnP devices on UDP/1900. Amplification factor, 30 times. SSDP is part of the UPnP, Universal Plug and Play, protocol used by smart devices, printers, cameras, routers, to find each other on a network. Attackers query these devices to describe themselves, sending the massive description to the victim. Key vulnerability, millions of IoT devices are mistakenly exposed to the public internet with UPnP enabled. WS Discovery, WSD, amplification. Windows-based discovery protocol. Amplification factor, 15 times, 20 times. 4. Directory Services Amplification. CLDAP amplification connection less LDAP on UDP/389. Amplification factor, 50 times, 70 times 5. RPC/reflection amplification. Port map/RPC amplification uses RPC port mapper, UDP/111. Amplification factor, 7 times 6. File and Network Management Protocol amplification. MEMC8 amplification extremely dangerous due to huge responses. Amplification factor, 10,000 times, 50,000 times, record-breaking. This is the heavyweight champion of amplification. MEMC8 is a database caching system designed for speed. Because it was originally intended for internal networks, many servers were left exposed to the internet with UDP enabled and no authentication. Impact, in 2018, this was used to launch a record-breaking 1.3 Tbps attack against GitHub. RIPv1 amplification routing information protocol v1, UDP/520. Amplification factor, 10 times. QOTD, quote of the day, amplification legacy protocol, UDP/17. Amplification factor, 10 times, 20 times. Chargen amplification character generator protocol, UDP/19. Amplification factor, 50 times, 100 times 7. Web and Application Protocol amplification. HTTP/2 rapid reset amplification, not reflection, but still amplification, modern L7 amplification without spoofing. Amplification factor, request rightward arrow reset flood ratio is huge, non-UDP, CoAP, IoT, amplification constrained application protocol, UDP/5683. Amplification factor, 30 times. TFTP amplification trivial file transfer protocol. Amplification factor, 50 times depending on file size. Chargen over TCP reflection, rare but possible. 8. Emerging or less common amplification types. NetBIOS amplification. UDP/137 responses can be large. Amplification factor, 3 times, 5 times. SNMP amplification. Some misconfigured SNMP agents respond with large packets. Amplification factor, small, 6 times. Attackers send a large number of SNMP GetNext requests to network devices, like routers or switches, using a spoofed IP. The device responds with a full dump of its management data. Key vulnerability, use of default community strings, passwords, like public or private. MDNS, multicast DNS, amplification example, Mac OS/IoT devices flooding responses. Amplification factor, 10 times. LDAP, stateful, rare for amplification. Some LDAP configurations produce large unsolicited responses. SIP amplification. SIP responses, UDP/5060, can be larger than requests. Amplification factor, moderate, 3 times. Top 5 most dangerous amplification vectors, historically. 1. MEMC8 amplification 10,000 times, 50,000 times 2. NTP monlist amplification up to 550 times 3. DNS amplification, any plus DNSSEC, up to 100 times 4. CLDAP amplification 70 times 5. SSDP amplification 30 times but extremely common in IoT devices. These were used in some of the largest DDoS attacks in history. Summary table, compact, protocol typical port amplification factor notes DNS 53/UDP 20 times, 100 times most common globally NTP 123/UDP 200 times, 550 times monlist vuln SSDP 1900/UDP 30 times millions of IoT devices exposed CLDAP 389/UDP 50 times, 70 times used in huge attacks MEMC 811211/UDP 10,000 times, 50,000 times extremely dangerous port map 111/UDP 7 times older Unix systems QOTD 17/UDP 10 times, 20 times legacy Chargen 19/UDP 50 times, 100 times still seen occasionally CoAP 5683/UDP 30 times IoT-only WS Discovery 3702/UDP 15 times, 20 times Windows Networks RIPv1520/UDP 10 times legacy routing TFTP 69/UDP 50 times based on file size. Summary comparison table protocol typical service max amplification transport MEMC8 data caching 51,000x UDP port 11211 NTP time sync 550x UDP port 123 DNS name resolution 54x UDP port 53 SSDP IoT discovery 30x UDP port 1900 SNMP device management 15x UDP port 161.